Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 19.1, which is going to deal with cross-sections and solids of rotation. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to describe the 3D shape formed by a net and describe a cross-section. So we're going to take a look at nets of 3D shapes, talk about what they are and how to identify them, and then also talk about how to identify the cross-section of a plane when it is inserted into a 3D shape. So that's the two things we're going to take a look at for today's lesson and what we're going to focus on. So the first thing we're going to talk about is nets. So a net is a diagram of the surfaces of a three-dimensional figure that can be folded to form the three-dimensional figure. To identify a three-dimensional figure from a net, look at the number of faces and the shape of each face. So, what is a net? A net is going to be this idea that if we have a three-dimensional figure, much like a rectangular prism. So rectangular prism means that I have a rectangular base on the top and on the bottom, and the sides are made up of rectangles, much like this. Now, a net is the idea that if I unfold this shape, this is my net. Okay, it's the unfolded representation of that 3D figure. This is a rectangular prism. Prisms have the same base on the top and on the bottom, and then its sides are made up of rectangles. So this is what a rectangular prism, what its net looks like. Now, we can do this with prisms, we can do it with pyramids, cones, cylinders, and spheres. Any 3D shape you can demonstrate through a net. Now, the key thing that we're going to talk about today is how to identify a 3D shape from a net. So let's talk about the differences between pyramids, prisms, cones, and cylinders. For prisms, a prism, if we think about this rectangular prism, a prism has two bases on the top and on the bottom, and then it's made up of rectangles. So when we unfold, or we have a net of a prism, you need to see a base and on the top and on the bottom, and then a bunch of rectangles in the middle. So because there's a bunch of rectangles in the middle, that indicates a prism, and then the base and on the top and on the bottom tells me what type of prism. So whether it's a rectangular prism or a triangular prism where we have our rectangles in the middle and then a triangle on the top and on the bottom. Something else that can clue you into what shape it is. Okay, triangle has three sides. That means I need to see three rectangles. A rectangle has four sides. It means I see four rectangles. Just as if we had a pentagonal prism, okay, so I have my rectangles in the middle, pentagon on the top, pentagon on the bottom, and I have five rectangles for five sides of the pentagon. And then the last one we've ever talked about is also a hexagonal prism, where I have my hexagons on the top and on the bottom, six rectangles in the middle to represent six sides of the base. So that is a prism. You should see rectangles in the middle and then the same base on the top and on the bottom. If you see rectangles, that clues you into prism. Then the top and the bottom is going to tell you what type of prism, whether it's a hexagonal, a pentagonal, a rectangular, or a triangular prism. Rectangles in the middle, the base on the top and on the bottom. So those are examples of prisms. Now, the other type of 3D shapes we've talked about is pyramids. Now, for pyramids, like I said, we have one base, and the side is triangles. There's a couple ways that we can represent pyramids. One way is in the middle, you have the base, in this case a triangle, and then you have triangles around all the sides of the base. So because it's a triangular pyramid, triangles have three sides, there's three triangles in my net. Now, most of the time when we go through and represent it on the homework, pyramids are just going to be unfolded off the base like that. But there are a couple other ways that we can represent pyramids. Okay, if we talk about a rectangular pyramid where you have a rectangle for the base and then you have your pyramid shape where the triangles are all around the sides and meet at one point, we can also represent a triangular or rectangular pyramid this way. We have a rectangular base. Because it's a rectangle, that means we have 1, 2, 3, 4 sides, and we have 1, 2, 3, 4 triangles. So if a prism indicates that you should see a bunch of rectangles for the sides, if you see a bunch of triangles, that's going to indicate you to a pyramid, and then your single base is going to tell you what type of pyramid. Triangular pyramid, because the triangle in the middle. Rectangular pyramid, because we have a rectangle in the middle. Just like the same with a pentagonal pyramid, because we have a pentagon, and because the pentagon has 5 sides, we have 1, 2, 3, 4, 5 triangles. And if I fold it up, then I get my pentagon little pyramid because I have a pentagon on the base, and then the sides are all triangles, making a pyramid. So you can have a pentagonal pyramid, and you can have a hexagonal pyramid. Hexagon for the base, 6 triangles to go around the base. So, pyramids. You need to see one single base, and then the triangular sides. For a prism, you need to see 2 bases, the top and the bottom, and then the rectangular sides. So if you see rectangular sides, that indicates you to a prism. If you see the triangular sides, that indicates you to a pyramid. Now, there's 2 last shapes that I want to talk about that we've spent time, and that is cylinders and cones. So if we take a cylinder, so a cylinder has a circular base on the top and on the bottom, and then we have a rounded side. If we demonstrate the net of a cylinder, you have your circular base on the top and on the bottom, and then we have flattened out that rounded edge. So cylinders have a circle base on the top and on the bottom, and then we flatten out that rounded edge. So that is an example of a cylinder. And then the last one that I have a net for is a cone. So cone, remember, you have your circular base, and then it looks like a pyramid, but it has a rounded edge instead of being made up of triangles. So if we look at the net of a cone, it looks like this. You have your circular base and then an almost semicircle part that goes around to form that cone shape. So if you see a net like this, this indicates a cone because your circular base and then the rounded top. Now, the only net that I do not have is a sphere. If you are intrigued and interested to know what a net of a sphere is, by all means, go ahead and Google it and look it up. It's kind of interesting to see how you can unfold a sphere. There's multiple ways you can do it. just kind of a fun thing to look at. So that is the idea of nets, and that's an example of 4 different prisms and 4 different triangles, and then a cylinder and a cone. So for our notes, the rest of the first page just goes through and talks about the different types of nets for the different types of 3D shapes. So for our first one, we have a rectangular prism. Prism indicates rectangular sides, and then the first name is going to indicate the base. So rectangular, that means I have rectangles for my base, and prism indicates that I have rectangular sides. So this is the net of a rectangular prism. The next one is a triangular prism. Triangular prism indicates that I need to have triangle bases, 2 triangular bases, and then prism indicates I need to have rectangular sides. The first name is going to indicate the base. The second part of the name is going to indicate the sides. Prism indicates rectangle sides. First name, whether it's triangular, rectangular, pentagonal, or hexagonal, indicates the base. Next, if we take a look at a rectangular pyramid, rectangular means that we're going to have a rectangular base. Pyramid means that we're going to have triangular sides. Again, whether it's a triangular, rectangular, pentagonal, or hexagonal, that indicates the base, in this case rectangle. Pyramid always indicates that you need to have triangles for the sides. So that is an example of a rectangular pyramid. Now, the last one that we have on the notes for a net provided for us is a cylinder, which we went through and talked about with my 3D shapes. So a cylinder, because we have a circular base on the top and on the bottom, and then the side is rounded, this is what our net looks like. The circular bases, and then the rounded edge flattened out. Now, the only one that they don't provide an example of a net for is a cone, but we will reference that here in a second. So, knowing all of that, that was a lot of groundwork to get us to our first example for today. But once we're into the examples, things will move fairly fast. So, example 1 is going to ask us to go through and identify what 3D shape is formed by the following nets. So if we look at example 1, part A, looking at this net, I see that we have a lot of rectangles and that we have 2 pentagons. So a lot of rectangles clues me into that it's a prism. A prism has to have 2 of the same bases. Well, we have 2 pentagons that can represent our base. So that means we're going to have a pentagonal prism because we have our pentagon bases and then our rectangular sides. And that is our first net for example 1. Now, the second net for B, so I see could be a square or a rectangle, doesn't really matter. So I see a rectangle in the middle, and then it's surrounded by triangles. So because I only have one square, and I see a bunch of triangles, that's going to indicate me to a pyramid because of the triangular sides. And then my base is our rectangle. So this is going to be a rectangular pyramid. Base is a rectangle surrounded by the triangular sides. So anytime that you have one base, one shape that's different, that's likely going to clue you into a pyramid. Now for C, we have 4 different triangles. Now, anytime that you see a bunch of triangles, that clues you into a pyramid. So this is going to indicate a pyramid, and because in the middle of our triangles we have a triangle, that's going to clue me into a triangular pyramid. So that is our 3D shape for part C. Triangular pyramid because we have a triangle base, and a pyramid because we have our triangular sides. Now, the last one for D, this was the last 3D shape that we had talked about when I pulled out my 3D shapes. We have a single circular base and then an almost semicircle shape. If we had 2 circular bases, that would clue us to a cylinder, but because we have 1 circular base in that almost semicircle shape, that clues us into a cone. And that is it for example 1. So I've gone through and talked about 4 different types of prisms. With my shapes, I talked about a triangular prism, a rectangular prism, pentagonal prism, and a hexagonal prism. And then we talked about a triangular pyramid, rectangular pyramid, pentagonal pyramid, and then a hexagonal pyramid. And then we've also talked about cylinders and cones. So you have seen a representation of all 10 of those shapes. Like I said, the only shape I don't have is a sphere, but that's one you could look up on your own to see what a sphere looks like unfolded. All right, so that is example 1. Now example 2 is going to ask us to describe a cross section for each figure. So example 2, what is happening here is they're taking a 3D shape, whether a cylinder, a cone, or a cylinder, and they are taking a plane and they are inserting it into that shape. So for A, they are taking a cylinder, imagine a piece of paper cutting through the cylinder, and they want to know where that cross section, where the plane and the 3D shape meet, what shape is formed. What does that cross section look like? So if we looked at example 2, part A, this is our cross section. Not perfectly traced, but you get the idea. So that red shape is our cross section for example 2A. So they've taken a cylinder and they've inserted a piece of paper in the middle of it. What shape do we get? We get a circle. So for example 2A, our answer is circle. All right, for example 2B, so they are taking a cone and they are inserting a piece of paper into that cone right down through the middle from the top. And the shape that is formed by that is this shape right here. So, what is the cross section of a cone and a plane being inserted from the top down? A triangle. So our cross section is a triangle. All right, last one for C. So again, they are taking a cylinder, okay, but instead of going through the middle with the cylinder, they're going straight down the top. So they're going right down the middle through the top, and the shape, and it's not fully well seen here, but I'll try to highlight it. is that purple outline. So, what shape is that purple outline form? A rectangle. So our cross section for example 2C is a rectangle. And that is how you go through and describe a cross section of a figure. So any different types of shapes, whether a circle, triangle, rectangle, square, you could do pentagon or hexagon as well. Those are all fair game for cross sections. All right, so example 2, that takes care of cross sections. We've talked about nets, we've talked about cross sections. There's just one last thing that I want to talk to you about for this set of notes. And that is example 3, where they want us to go through and describe the 3D figure that is formed by rotating the following shapes. So for example 3, they want you to take the following shapes: a triangle, rectangle, and a semicircle, and they want you to rotate 360 degrees around the following lines L. So imagine if you could rotate this shape in a circle around that line, what 3D figure would you get? So for example 3A, if I took that triangle and I rotated it around that line L, we would end up with a cone. Because if we rotate in a circle, that's going to give me a circular base, and this triangle is going to form that cone-like shape where it has a rounded edge and it meets at one point called the vertex. So, for example 3A, we get a cone. Now for example 3B, so if we take a rectangle, and if we were to rotate it in a circle around this line L, so if I were to rotate this 360 degrees around that line L, we would get a cylinder. Okay? Because imagine, again, if we're rotating in a circle 360 degrees, that's going to give us our circular base, and because we have a top and a bottom, that indicates to a cylinder because we have a top and a bottom, and that circular shape is going to be formed by the rectangle for the side. So for example 3B, we get a cylinder. And then the last one for example 3C, so we have a semicircle that we're rotating in a circle around this line L, and the shape, the 3D shape that we get is a sphere, because imagine rotating a circle 360 degrees around, because we have a circular shape. Okay, if we rotate it all the way around, it's going to end up giving us that spherical shape, giving us a sphere for example 3C. And that answers all of our parts for example 3, and that completes our note for section 19.1 on nets of 3D shapes and cross sections. So today we have talked about nets, cross sections, and then shapes that can be formed by rotating shapes around a line. Remember, when we are talking about nets, it is the unfolded representation of a 3D figure. So if we go back to, for a second, okay, our rectangular prism, that's the first 3D shape we talked about. If I unfold this rectangular prism this provides me with this following net. Remember, prisms are going to have a bunch of rectangles, and then your top and bottom base is going to indicate what type of prism it is, whether it's rectangular, triangular, pentagonal, or hexagonal. And then pyramids are going to be made up of a bunch of triangles for the sides, and then your base is going to be indicated by the one single shape that is not a triangle. You can have a triangular pyramid, or you get a bunch of triangles as well. So, pyramid, you need to see a bunch of triangles. Just like a prism, you need to see a bunch of rectangles. And then just to refresh your memory for a cylinder, okay, circle base on the top and bottom, and then flattened out middle, and then cone, because we're going orange and orange here. You have that single circular base, and then that kind of semicircle shape for the top. So that is our note for section 19.1 on nets and cross sections. So that is it for today on our notes for section 19.1. I hope this video was helpful, and I hope you have a fairly good idea of what a net tells you and how to identify what 3D shape comes from a net, and then being able to identify a cross section. So that is it for today. I thank you guys for listening. I hope this was helpful. If you have any questions, as always, please reach out via email or just touch base with me next time you see me, and I'll be more than happy to help or answer whatever questions you have on the notes or any other 3D nets or on the homework as well. So thank you guys for listening. I hope you have a great day. Good luck on your homework. Be sure to reference the completed notes or come back to the video. Otherwise, that is it for today. So thank you guys for listening, and I will talk to you guys later. All right, bye.